So as I was saying to somebody earlier, there's a lot of directions I could take this. I don't like just giving talks and reading off a slide. So if you have questions, stop me. If there's something you'd rather me talk about as opposed to the direction I'm taking it, there's a lot of ways we could take this. Like I said, I already have one 35-minute video on this topic. I just did an interview with Vicky Froen, who was the first person to use this term context graph in 2019. So despite what you may have heard, he was really the first person that we can find to use context graph in this context. Haha, there's going to be a lot of those. And yeah, it's interesting because I love that slide, Elvis, that you had about data 3.0, because, and that's kind of what I'm going to get to with this slide, is that enterprises have created this very complex data estate now. So many products, they're all chained together in very complex ways, and they're really all built around row columnar data tables. And so when we start talking about graphs, graph systems really don't fit well into any of that ecosystem, which is going to be really interesting. It's going to present some interesting challenges. So best we can tell, and this has come to us from quite a few sources, including people at McKinsey, around November or December, the term context became just a huge topic in enterprises. My thesis is that's because they were doing their year-end reviews, and basically all the AI POCs that people have been doing for the last year or so, they didn't make it to the next phase. I mean, so they're starting to do reviews and like, why did they not make it to the next phase? And all of a sudden, this concept of context as king just emerged. It's like all the C-suites and enterprises around the world just had, massive groupthink, something like, hit with this ray of light, and they go, context, that's what we were missing. But in that, well, actually, let me get to this first. So there's a lot of reasons why we think that AI POCs failed. These are kind of the three that I think are the most telling, maybe potentially. It sounds right, but it's wrong. We know that LLMs can be very confident about what they say and still be very, very wrong. That's a scary problem for an enterprise. If you have employees depending on it, or you have this totally automated process, and you get to the end and very confident declaration, I have done the job, and somebody goes, yeah, that's wrong. Then there's the other one of, I think we've seen this one a lot too. The POC itself kind of worked, but they didn't know how to measure that in terms of business value. They're kind of like scratching their head going, like, what do we do with this? Does this mean we fire a bunch of people? Does this mean we can do more things? Does this mean we need to change our planning and our cadence? Like, what does this mean? Like, we don't know how to get value out of this. And the last one, something probably everybody here is familiar with, is all the lawyers and the data governance and all the compliance team are going like, whoa, just stop, just pump the brakes on everything. And apparently at some point, people started saying, well, context, that's the problem. That's what we need, context. And then also like decision traces came out too. And this concept of system of record. And that got attached to this idea of a context graph. And if you go back and read the article that really kickstarted all this, I think, what's it called? Context Graphs, $1 trillion AI opportunity, the one that Foundation Capital wrote. They really focused on this aspect of it, the decision traces. And it's interesting is that author, she's even tried to downplay now. Like, she actually commented on one of my posts, like, well, it doesn't have to be a graph. I'm like, it doesn't? Wasn't that the kind of the point? And now she's even backtracked that on herself. I've seen with some of her recent posts, because they've been piggybacking off of Glean trying to jump in on this, which very interesting. But what does this mean? What does this mean? Context. And again, stop me if you want me to dive into one of these. This is kind of what the RAG process, for lack of a better term, has been. The only difference here is instead of, vector embeddings, and that's where we're retrieving chunks, now we're talking about storing data in a graph. So I guess this is actually a good time to ask, how many people have actually worked with graph systems, like a Neo4j? Okay. Have you ever by chance worked with like semantic web style graphs, RDF? No. Okay. So that's not unusual. like again, that data 3.0 slide, the entire enterprise data estate is based around data tables. Probably the only place a lot of times that you see graphs live are in the fraud teams because they're using graphs, and some other stuff, cybersecurity, they're using graphs. But then you also know that the cybersecurity team stuff is usually in its own little sandbox. It's over here. They do their own thing. And same thing with the fraud and the KYC people. Those systems tend to be their own thing because they don't fit well into all of that connected ecosystem that is all of the data products that we have today. And so the idea is simply that if you take the semantically rich structures and we give that to an LLM, we get much better results. And you're probably thinking, well, what does that mean? So my definition of a context graph, which I'm pushing very hard for, I really, really hope we can get this to be the prevailing wisdom, is that it's simply a subset of knowledge graphs that has been optimized for AI usage, which is, I don't think, too hard. I don't think it's too complicated. It is still a graph. It is a semantic graph, and there's lots of ways to do it. We're adamant there's lots of ways to do things. Matter of fact, we do lots of things multiple ways in TrustGraph. So, but the context graph, again, a lot of people focused on this system of records part, but they kind of left out this part, the system of initial intelligence. And what you can think about that, like if you've done vector RAG now, that would be like all the chunks and all the embeddings that you've created. So you have all these embeddings that help you retrieve chunks. Like you try to create this system of intelligence to provide the LLM so it has the right context for any sort of request. Now we're just saying, well, we want to do all of this in a graph. But what does this mean? A system of records. And what is this part? This system of generated intelligence.
Real quick,
yes.
Where would you see a semantic layer? Would it have a role here or elsewhere?
So the term semantic layer, the way it's used in kind of what I'm saying now, like the columnar data estate, is not the same as what I'm saying with a semantic network in the sense of a graph. Yes, no, kind of. There are some similarities, but and that's one of the things I hope to. And it may just be too much for this conversation at this length about why they're different. But let me go into a couple more slides and see if it helps. Because the first thing I need to do is explain what a triple is, because graphs aren't made up of rows and columns. Well, actually, they kind of are. Shh, don't tell anybody. Because our default graph store in TrustGraph is actually Cassandra, which is funny because people like, I'm actually friends with the CTO of Neo4j, and he still, I don't think, believes me that we use Cassandra. It's like, how could you do that? That's not possible. I'm like, you know, we do it. Which, of course, if you actually look at most of these graph database, like knowledge graph systems, at their core, they are some sort of columnar store system, like Nebula Graph, which is a really nice knowledge graph system built on top of RocksDB. They just kind of made it multi-node, which again is a different kind of node than these kind of nodes. Ha. So this triple, subject, predicate, object. You sometimes see verb. That was kind of used a long time ago, but the better way is predicate. So like you take these things like Alice and Bob. So Bob would be the child of Alice. How does that get translated into a subject, predicate, object? It would be Alice is mother of Bob. That would be a triple. And you kind of see some other examples. So a graph would just be a set of these. That's why sometimes we call them triple stores. And now how those kind of relationships get structured in the graph, that's kind of a different thing. So this is where the knowledge graph world gets very evangelical about what's right and wrong. And now I don't want to say what I was about to say. Both sides think they're right. We say both sides have a point and you can do it either way. So the most commonly known way, like I said, if you know Neo4j, Nebula Graph, FalcoDB, MemGraph, any of those types of graphs, they're all property graphs. They use Cypher as their graph query language, which is now an ISO standard called GQL. And they basically, you do stuff like this, and then you're able to add properties to that edge. This is known as an edge, nodes, edge. Now, this one goes back to the 90s, RDF. It's resource development frame, resource, I can't even remember what it is. What's that, someone? Yeah, I can never remember. It's harder to learn, way harder to learn. I'm going to get into this because it's not well documented, and it's not, it's common and it's not at the same time. It was basically this idea of the semantic web, that it was a way that we were going to interchange information through websites. So like I said, this comes out of the late 90s. So people were envisioning what the web is going to be. They said, well, we need to create a language for exchanging data. And that's kind of what this came out of. And this has this entire ecosystem underneath it of ontologies and other standards, and lots of ways of doing it. That's another thing. And it also has its own query language called Sparkle, which is very SQL-like. So an example. My co-founder, Mark, of TrustGraph, he's actually in the UK. Years ago, when he was trying to teach me RDF, I was just like, I don't get it. So he wrote me a guide using his cat, Fred. And we have this guide, by the way, on it's on our website. It's linked on, it's in a GitHub. You can find it. He takes 3 statements. Fred lives with Hope because this is Fred. Hope is also a cat. That's another point. Fred is a cat, and Fred has 4 legs. And what it takes to structure it as RDF. And this is not all of it, by the way. This is just some of it. And this is also just RDF turtle, by the way. This is the most human readable format of RDF. It's kind of YAML-like in some ways. You have a lot of indents and stuff like that. You have all these URIs, which also, that was the first thing that confused me, because I'm like, example, like what? Why are they, like, they don't actually matter. They're not necessarily linked to something. Although you can, which makes it more confusing, but they don't actually have to mean anything, except these, the RDF one and the RDFS one, actually do mean something. Those are standard in the standard. I know, we're getting confused, aren't we? It's a little bit of a learning curve, no doubt. And then you get things like this. So this one, who here has ever dealt with, not necessarily recently, but years ago, SEO for Google? Anybody ever have that fun? Okay. Did you ever do the enhancements, the schema.org enhancements? Because yeah, so they're not really relevant anymore. Like Google even admits, like, we don't really use them anymore. But what that was is, if you go to schema.org, it is an ontology. That is an ontology. It has terms, it has definitions, it has possible values, because underneath the hood, Google search is a graph. If you know anybody, or if you've ever worked at Google on the search team, those are graph experts. They live and die with graph theory and all of this stuff. Now, there are other ontologies like, oh geez, there's so much stuff we can get into. Like, this is more like a taxonomy. So it's, terms, definitions. Then you have things like SCOs, which enables you to define concepts. So as you can imagine with ontologies, you have so many options of just not defining things like terms and definitions, but then like what domain it lives in. Like, again, like, a cat, and this is part of a mammal, it's part of animals. Then you attribute like the Fred as a cat, and then that's all connected to all of these things. So that, whereas before you might have like all of these taxonomies and definitions like on, multiple pages, now they're all actually connected together with a relationship, so that if you query one and you pull it, it's going to pull all the rest if you ask for it that way. There's lots of different ways of doing graph retrieval. As I said, you have this network of nodes and edges. You can do things like deciding, like, I want to get from here to here. Which path do I take? You can choose the shortest path. You can choose the longest path. You can specify, like, I want to start here. You can specify how many nodes, how many hops that you make. You can start looking at, and, are nodes clustered together in relationships? What's the density of those? And this one actually is the big one, is anomaly detection, finding those outliers, finding that thing that maybe has one connection. It's connected to what I'm looking for, but it doesn't seem like it's not clustered with anything else. It's not part of this community. It's just kind of like there's a connection to it, but it's like, what is that? That's usually the most interesting data points, or those anomalies. And basically almost every cybersecurity product out there, that's what it's doing. Same thing with your fraud and KYC. Every time you do a credit card transaction, there's graphs being queried looking for like, hey, is there something anomalous about this? How many times have we gotten like that message from our bank like, hey, this is suspicious? It's basically this. Oh boy, reification. So I was talking about that system of records thing and the decision traces. Whew. Okay, buckle up. We're really getting into the weeds of graphs now. The decision traces aspect of context graphs that people are really latching onto is this idea that, an AI agent is performing tasks, it's using information, it's then creating new information. How can I capture what's going on with that? And can I structure that in a graph? Well, the natural way of doing that is what's called reification. And as I was telling somebody earlier, that is the technically correct term. I don't know if we're going to continue with that term because it sounds a little weird, although reified AI agents also maybe sounds cool. I don't know. You tell me if you like it or not. This is still the best definition I've found. A statement about statements. You're probably thinking that sounds kind of vague, and I went, if you'd seen the other definitions, you'd be like, yeah, give me that one. So again, Fred, our friendly cat, he's got 4 legs, okay? Now say Mark has told me that Fred has 4 legs, and he told me that today. And that would be like a decision trace. Well, not really a decision, but hey, go with me for a second. We want to attribute that Fred has 4 legs to who stated it, because maybe an AI agent said it. So this would be reification. Now in the RDF style, this gets a little weird. We kind of have to create what's known as a blank node, the statement node, and then we connect these things to it that says, Fred has 4 legs, asserted by Mark, and when it was asserted. While this gives us all that information, these things aren't really connected in a really tangible way. So you can query this, but it's a little bit more complicated. You have to really understand you have to be a Power Sparkle user. Property graphs were really made for this. They do a great job. You have an edge, and you just append those properties. Boom. Now, what's interesting, seems like all this is just happening at the same time, magically. The RDF working group, in the beginning of December of 2025, issued RDF 1.2 draft. Yes, the thing that came from the late 90s, they just issued RDF 1.2. They are operating at a blazing pace, that working group. But I'd actually love to talk to them because it kind of seems like they knew this was coming, because what's the biggest thing they added to RDF 1.2? A much easier way to do reify nodes and edges in RDF. It was like, wow, that was kind of serendipitous timing. Why does all this matter? Well, when we talk about LLMs and language, and this stuff that doesn't fit neatly into tables, it's not a key and a value. It's not like the number should be 3. We could say the same thing multiple different ways. That's the nuance of human language, because we're talking about a tool that we use to exchange information between humans, which means there's multiple levels of this. Unfortunately, this idea comes from Noam Chomsky. I don't mention his name too much because he was friends with somebody who's very much in the news these days, so he's kind of canceled. But he was onto some smart stuff here. Competence, do you know the right thing? So do you have the right context in your context graph? Do you have the right frame of reference? We're talking about data products. Do we have the knowledge that we need to understand why you wire Kafka and Flink together and how that compares to other durable execution platforms? Do we have that competence? Do we understand it? But for performance, even if I know that, even if it's in my head, can I exchange it to you in a way that you go, oh, okay, I get it. I mean, take this talk. I have all this information in my head, but every single one of you are going to have a different point of view on whether or not I was able to convey it to you. And then, is the information even relevant to the question that's being asked at all? The other one, I said at the beginning, the third layer of the context graph is what happens when we have these AI autonomous systems generating new data. And again, this isn't just logs. It's not just timestamps and values and strings that are all of the same length. It could be a paragraph. It could be code. It could be images, video, so many different things. And if we have these truly these autonomous systems that are now performing all these tasks, well, that stuff that's getting generated, that's our new data. So we're having to close the loop, and that new synthetic LLM generated, that agent generated information, that's now our new context for what happens next. And then we start getting into things like context drift. This new context that's being created, is it different than the old context? Is that a good thing? Was the initial context wrong? Has ground truth changed? Maybe it never was ground truth. So then we start having to look at these temporal relationships. I actually have, I'm sure somebody has said this before, but I like to say that truth is not as black and white as we humans like to think it is. And that the closest that we can get to ground truth is something that always was and always will be. No matter how many times we observe it, it doesn't change. Everything else, yeah. Going back to the decision trace thing, there's lots of factors that weigh into human decisions. That's another reason why talking about decision traces and context graphs a little difficult. And just want to throw this up there. So TrustGraph that kind of does all this stuff, which is open source. We've been working on it for about 2 years. Somebody at McKinsey said I should call it a context harness. And I'm like, well, people pay you guys a lot of money, so I'll give it a try. So we would love it if you check it out. If you're interested in graphs, context, what we're kind of seeing is that we think that we don't see this as a replacement for that slide you had, Data 3.0. It's probably going to be something that exists in parallel to it. Because, this is something that we've spent the last 2 years trying to figure out, like, where do we wedge ourselves in here? And lately, it's kind of become obvious the answer is don't.